Hi students. Okay, this is chapter 5, section 5.2.2, finding a rule for linear relations. So, first of all, what is a rule? What are we talking about here? Let's look at an example. Y equals 3x plus 1. This is a linear rule. And, for example, if x is equal to 1, I can generate what y is. 3 times 1 plus 1 would be equal to 4. And I can do this for any number, for any value of x. If x is 2, y would be 3 times 2 plus 1, which is 7. So this is the rule. But what happens if it's the opposite? What happens if they're giving us the numbers and we have to find the rule? Well, let's look at an example. This is worked example 2. So here are the numbers, 3, 7, 11 and 15. It's a linear relation. The first thing I'm going to do is label them. I'm going to call this term 1, term 2, term 3 and term 4. Excuse the writing, but you know what it's like. I look at the common difference between these numbers. Between 3 and 7 there's a difference of 4. 7 and 11, a difference of 4. 11 and 15, a difference of 4. So it's a linear relation. But now I've got to find the rule. So the first thing I do is I know the common difference is 4, so I'm going to start with y equals 4n. I'm using n instead of x. And I test it. Now, if n is 1, then 4 times 1 is 4, but y is 3. So that's not correct. But I have to add or subtract something in this rule to get that. So what would you subtract from 4 times 1 to get 3? 1. So let's try the next one. This time n is 2. 4 times 2, in this case y is 7. 4 times 2 is 8, but y is 7. What do I subtract 8 from 8 to get 7? 1. There's a pattern emerging. Let's look to the next one. This time n is 3. Y equals 4 times 3. 4 times 3 is 12, but the term is 11. What do? Subtract 1. So therefore there's my general rule. Or the general rule is y equals 4n minus 1. And that's the rule for that linear relation. Now look at the next video that I've given you, and that shows you a couple of solutions for some of the exercises in 5.2.